Welcome back. So this is part 2 of our question answer chatbot. So first we will see the process flow. Suppose we have a text corpus. So it will be first sentence tokenized. Then we get many sentences. Fine. Now from these sentences, each sentence we will be working with word tokenization, lower casing, POS tagging and lemmatization. So in the part 1 we have already done this, which one is in the white box. So we worked it and we made a function, we created the function, and today we will be working on the upper part. You can see that text, sentence tokenization and sentences. This is also a part of this pre-processing, but to keep it simple, we did last day, we considered the text as only a single sentence as our corpus or text. Fine. So now in today's part 2, we will be basically doing feature engineering or feature extraction. So we have already done some pre-processing steps. Now we need a way to feed this pre-processed text into an ML algo. So here comes feature engineering. Here we have a set of tasks that captures the characteristics of text into a numeric vector. So basically the steps will be involved. We will be focusing on the scikit-learn library. We will be doing that TF-IDF vectorizer. We will be working with this cosine similarity and few things will be there. Why we are doing this? Because we know that when we have text, machine doesn't understand text. So somewhere we have to convert it to some vector form. So here we will be doing this. After that we can use it for our model. Fine. So let's see what is there in our part 2 part, where we will be finally giving one question to our model and it will be answering back from the corpus which will be matching. Fine. So let's start with our work. Okay. So first let's rename our notebook. So I am renaming it to as part 2 because we already have part 1. So first thing first, let's take our corpus. So I am again naming this variable as text. Now I have already collected this paragraph and I have made ready these 5 questions for this paragraph. So let me copy and paste it as a long string. So for this, to keep this simple, I am just taking a paragraph. Now see here are only 3 sentences, but you can use some scraping techniques, or there are many techniques to fill this gap. Okay, so you can use any technique and we will be using in coming small mini projects. We will be using in a simple way, we will be using those techniques. Fine. Now this is the chatbot 1 part. So here I have discussed everything and finally we have created this part. Now I will just copy it and paste it. Now if you want to explore more, you can I'll be keeping that link. I'll be connecting that link in the description so you can go through it. Simple. Now I have just pasted. Now I'll just describe it a bit. Now first, here I have used only NLTK for this pre-processing part. In the previous, when we did with that ebook, there I have used something else. So you can watch that mini project also. That is also very simple one. Now main thing is that this function. Now see, here I have written text and I have done word tokenization. And the text is first lowercase, then the word tokenization is done. Simple. And now this send token is containing a list of words. Now that list of words is first we have done POS tagging, means parts of speech tagging. After the parts of speech tagging is done, now those words are lemmatized. Lemmatized means those words are brought to its base form. So how it is done, you can find it in the chatbot part 1 there. Now we have to change a bit because now our corpus text is containing more than one sentence. Previously we did with one sentence only in the text. Now here we have more than one sentence. So per the demand, this function accepts only one sentence. So I am just changing it for our better purpose. Fine. So now this much you need to change and everything is okay. Now let's understand in a very simple way one by one. So first let's see how a single sentence is tokenized. Means how word tokenize this function is working. Now see, sent match, this is our function, and we will put single sentence for it because we want to see what tokenization first. Then we can compare with how sentence tokenization is working and what is the output, because if we know the output properly, then only we will be able to understand actually how the steps are working. So let's first print this L1. Now see, after this word tokenization of single sentence, you can see we got a list of words. Now here lemmatization is done. For that, R is converted to B, living is converted to life, and you can just see one by one word how it is being changed and why and what, everything is discussed in the part 1 section. Now you got it how word tokenization is being done for single sentence, how our function is working. But in this text corpus we have more than one sentence. For that we need something called sentence tokenization. In the slide we saw that text is converted to sentences, then sentences from there one by one sentence is taken and then it is converted or it is tokenized, and finally we are getting the lemmatization part. Now here we see that what tokenized. I am just simply copying it and pasting it. So in place of this word there will be sent. So what tokenize and sent tokenize, these are two different things. And now this sent tokenize, for as argument it expects that there should be a text. Now what this sentences tokens is containing, let's run it. Okay. Now see, it is a list of strings and one string is containing one sentence. Now it is quite intelligent that it understands from where the sentence is starting and where the sentence is ending. Simple, here we don't have to worry much. So this part should be done before word tokenization. So we will be putting it here. So everything at one place. Now we don't need this, so I am just deleting it. But I will keep this part, so I'll just put hash, so it will not work this much. So this much is clear, I hope. So here in my YouTube channel you will find very simple projects because this is for students only. And now we will go with the next part. Now see here TF-IDF vectorizer is a class, okay, and this class is from sklearn feature extraction.txt. So this is a module, simple. Now this is used for converting, that we discussed, a collection of raw documents into a matrix of TF-IDF features. So this class actually is doing a statistical analysis which will mainly find the importance of the word. Now in the next line we have executed that cell. Now if I click here and press shift tab, I can see the signature from here. So you can also do that. What actually it is telling, you can find it from here. Now we have initialized our class. Now as the class here as an argument, it expects this one. So what we have to write here, the tokenizer is a parameter which is used to specify the function that we will be using to tokenize or split input text into individual tokens, that is words or terms that we just have seen. So this much is clear. Now here you can see that I have written sent match without a parenthesis. When we use send as an argument, so we don't use that open close parenthesis, because that's why I have written tokenizer equal to sent match, because sent match is passed, this function is passed as an argument. Fine. Now initialization is done. Now the next thing that I am writing, TV dot fit transform. So what it will do? It transforms the inputted data into document term matrix. So here actually the thing is happening. So we have to write these two lines, one by one. Now see here it is written 3 into 23 sparse matrix and the class is numpy. So you can see it. Now why it is written 3 into 23? Now let's see to it. Okay. Now we have our text. Now let me just show it before we discuss it. Now tf.toArray, because it is a numpy class, we can use this function. Now see here 1, 2, 3, 4, 5, 5 2s are 10, 15, 20 and 23. Now see how many are there. So list of lists. So one list, each list is containing 23 now different numbers, and there are how many lists inside the big list? There are 3, because in text we actually have 3 sentences. That's why here it is represented like this. And why 23? The maximum distribution done, means the number of different words it got is 23. Now we will see in a better way using this pandas. So how we write? Import pandas as PD, because we know pandas gives us a tabular representation that is much more means easy to see and understand. Now we are actually making a data frame. So data frame is a table types which has rows and columns. For this we are providing this TF-IDF as row, and for columns, that means columns will contain the name. Then it will be easier for us. Names, what it is? These are the words. Now see, there are 3 rows and 23 columns. All that means lemmatized words are appearing as heading. Now it is much more easier to see and understand. So this is how these are the weightages of these words. Its weightages. Now we will do some cosine similarity. Now cosine similarity course, we will be taking first one question, because similarity there should be 2 identities. One should be a question and it will find something similar to it from the text part, simple from the paragraph part. So there should be 2 identity amongst whom we can find the similarity. So I am putting the first question over here. Now we have to execute this cell, otherwise it will not understand. But before that, let me just do something more. So here I will put this sentence tokens is first containing what? Those 3 sentences from that text part. But question is also one sentence, so it should be appended. Now sentence tokens is nothing but list of those 3 sentences, or how many it can be. Now with that, at the end we will append this one also. So as it is a list, we can do this append function. Now the question is also appended. Now let's see it. For that only I have not deleted this cell. Let's see how it looks. So after executing, so let me just put this one also, sentences underscore tokens, otherwise how we will see to it. Now see, now this list of strings is containing our question also. Now there are 4 sentences here. Till this it is okay. Now I am restarting it and running it all because we have added so many things, so we have to restart and run all these cells. Fine, all these boxes we have to run it first, so it will just take some time. Now one more thing, see here, now it has become 4 into 24. It got a one more word, new word, and there are 4 lists. Here also it has increased. See, previously the matrix was containing 0, 1, 2. Now it is containing 0, 1, 2, 3, means 4 rows and 24 columns are there. Very simple. Now we will compute the similarity between whom? The question and the sentences which are there. The most which will match might be the correct answer. So let's see what actually it is. Now similarity matrix. Now we are initializing this also. Now cosine similarity scores actually we get is useful for tasks such as document clustering, information retrieval and recommendation systems. We will be working on this also. Now for now we are providing TFC, I am writing -1. So this is the index position because our question is at the last part. So last part means from the reverse order, if we see, we know that it is -1, then -2, this way it proceeds. Now after similarity it has given us the score. So you can see that the last one is matching 100%. Why? Because the question matches to itself, so it will be always 100%. So this one we don't want. Now what we want? The second highest. So this one is the 0.58, means amongst those 3 sentences the first sentence is matching more. Fine. So it's nice, right? Now we need to find the index position of that sentence which is in the text corpus. So for that I am just collecting it in this similarity matrix index by using sorting function. So similarity matrix, now we have you can see 0.58 and this is a list of lists. So on this we will be using the sort function. Now inside the outer list, this is the inner list, so the position of this list is 0. So we have to specify this, and from there if you start from the last position, so we need actually at which after sorting it will be always the second last part. So the index means similarity matrix first will sort and take the index, then it will arrange it. Fine. So you can just, before putting the 0 and -2, you can just run only the sorted part, then you will find it in a much better way. So at 0 number position we have that 0.5 at this part. Okay. So now next part what we will do, so we will just flatten this matrix because it is a list of lists, so we don't want that. So make it simple, we will just flatten it. So after flattening it, let's see what is the result. Always for each step we will keep on seeing the result. So now see, after flattening, this is our result. Fine. So see, programming can be done in many different ways. So this is one of the ways I am working on. You can try it in some different way, different order. So there is always a chances to do in a different way. Now this flattened array, now we have just sorted it. Now let's see after sorting what we get. So this is, so at the -2 position we have this what? Similarity score. First we have collected the index position because that is matching to the text corpus. Now we are actually taking the coefficient values. Fine. So these two are different things. Now similarity matrix flat, which one? -2 position. So we are collecting this 0.58 in our COEFF, this variable. Now we will just keep a threshold that if it is matches at least some percentage. Now let us consider if it matches at least that 30% of matching is there, then only we will be printing the answer, otherwise not. So sentence tokens is containing all the tokenized sentences, and the similarity matrix index is containing the index value of the similar sentence. So after running we got this answer. So let's just see or copy and paste the question below, then we will be able to means relate it more nicely, right? So let's do it. So this is our question. So what are the two main things plants need to grow and make their own food? So see, here it is to grow in soil, it uses sunlight to make their own food. So it needs soil and sunlight to grow and make their own food. Now let's take this second question in consideration. So we will be always testing, because this is not a full and final thing, but for understanding purpose it's a very nice thing to work on. So let's run this kernel from restart and run all. It's always better to do this, because running all the cells one by one is very difficult. Now see, after running this we got the coefficient score as 0.07, which is not greater than 0.3. So it is unable to find the answer. Now let's take one more example. So let us take this fourth question. So you can do it according to your own way. So this type of simple projects you will get in my channel. For that you need to subscribe my channel, and if it is helping you, do subscribe to my channel. Okay, again I will run all the cells. Now let's see after running. Now here we are getting the score 0.40, which is greater than 0.3. So let's change the question so that we can relate the answer with this. So what are some examples of food that plants provide for animals? So here plants give us oxygen to breathe and provide food for animals like fruits and vegetables. So it is matching. So this is it for today. We will meet with some different project. By that time, bye bye.